First of all, thank you for having us. In today's presentation, we will focus on how data can enable outcome-driven design. But before we deep dive, I would like to tell you about my colleagues. We are 110 people based in 7 different locations from 15 different nationalities. And our backgrounds vary very much, right? Me, for example, I'm an architect. Raoul is a real estate developer, but we also have data scientists, PhD people on physics. And the whole idea is to bring all these people together to solve a very important problem. And that problem is how to plan and build better cities. This is a very complex one. And as stakeholders in this industry, we need to consider multiple constraints, dimensions, like density, the functions of the buildings that we are drawing, as well as living qualities such as the wind, the sun conditions, and even the impact that our project development will have at a slightly bigger scale, at the neighborhood scale, but also at the city scale. And of course, we must consider zoning, regulation, requirements, which are, at the end of the day, a set of rules that were created to enforce good living conditions. And on top of all of this, we have all the stakeholders with multiple backgrounds, right? And multiple interests. We have the architects, the real estate developers, the planning authorities, and even the people that live on that neighborhood. It's an extremely complex setup, and we know that it needs to happen very quickly. There is a not new, but very urgent urbanization trend. And in order to keep up the pace that we are seeing on the urbanization, we need to build a Paris city every week. That's kind of shocking. And we need to do it fast, and we need to do it well. And how is really our industry responding to this urgency? Well, I don't have so good news for you. Construction is actually lacking behind when it comes to productivity. There are a lot that has happened, of course, with the BIM revolution, but we have failed to make digital investments in early phase development. However, there are good news here. According to Skanska, more than 50% of the value creation takes place between concept and design and planning. 50%, that's quite a lot. And how is Spacemaker solving this problem? So our technology has 4 pillars, and that's about automated data, real-time analysis, AI-powered design, and project management and collaboration. Today, we will focus more on the data rather than the generative design aspect. And everything starts, of course, in the automated data. I will now show you a very quick demo on how a project is created in Spacemaker. So the only thing you need to do is to go to a service that looks very much like Google Maps, write the plot's address, and in just a few minutes, Spacemaker fetches all the data you need and creates a 3D digital model of the whole neighborhood. The data that the software will fetch for you consists of the terrain, maps, property limits, surrounding and existing buildings, as well as noise sources. So this is incredible, right? In just a few minutes, we have this 3D digital model. But then this is where the data, the external data is coming to us. Then what the software does is really to start processing this data, right? We want to understand what is special about this site. What are the potential aspects, but also the challenges. And Spacemaker runs a multitude of different analyses. These are just some examples. On the left-hand side, you have sun, daylight, noise, wind. So all of the important living qualities, not only for the project, but also for the whole neighborhood. I think this is a very important aspect, focusing not only on the small scale, but also on the big scale. And this is particularly interesting when it comes to performance-driven design. We want to understand how our buildings, our projects, how they perform not only in absolute numbers, but we want to understand that in the context of the urban setting where they are being developed. And in order to understand that, what we have done is to study the most popular neighborhoods all around Europe to try to understand what kind of qualities those neighborhoods have. And this is the example you see here on the screen. It's Majorstua in Oslo. And what it creates, it's a baseline. We can now actually compare our projects with neighborhoods that we know very well, that we know the qualities that they have, and we can understand if we could do better, if we are a little bit under, how much we should stretch or not. And this is just one example, Majorstua, but we have actually analyzed for many different neighborhoods all around the world. And what I would like to underline here is the outcome-driven design aspect. So let's first start with the current status quo. Let's say I'm an architect. I've now started a project. I've spent some months with my colleagues trying to develop that concept, making it very matured, discussing it a lot with my project team. And once we are very confident about our design, what we would do at that stage is to send over this 3D model to a consultant, let's say a noise consultant, which then would analyze our model. We'd point out the red flags, right? Saying you need to revise this apartment here, it's exposed to too much noise, would advise me how to solve that and send me over a PDF with all of those recommendations. Then I would iterate my model. And at the end of the day, that PDF that took me weeks and I paid a lot of money to get will be completely outdated. In Spacemaker, that process is happening in minutes. All of those analyses are happening in the cloud, and I can see immediately what kind of impacts my designs have on the neighborhood, but also on the project itself. But we would like to take this like one step further. For example, noise, it's something that requires a lot of computing power. So it's taking now some minutes in Spacemaker, which is incredible, right? We are going from weeks in just a few minutes, which is kind of insane. But outcome-driven design takes place really when you can see things live. When you draw something and you can see immediately the impact that that iteration has on your project as well as on the neighborhood. And we really believe that's the future. It's about the performance of the buildings for those that use it, but also for those that live next to it. And what you see here is our project on machine learning for noise. So we have thousands of noise analyses that have taken place in Spacemaker. What we do is that we build up a data set out of it, and we feed that data set into our machine learning algorithm, which then will create a surrogate model which predicts how would be the noise conditions. And now I will play a video on the right-hand side, and you can see there. So we have these buildings just by making this one short, and then I just click on the button, and I see immediately the results of that iteration. And I do the same there, and I see, again, immediately the results. This it's having information at every step of the process. That's really what ultimately will enable us to create better cities. And again, we are very focused on noise because it requires a lot of computing power. The same is true when it comes to wind. So we are following exactly the same logic. But now I would like actually to invite Raoul, my colleague, to explain you how this technology can be used in very concrete use cases.
Thank you, Daniel. Yes, as Daniel said, I will now dig a bit deeper into how it works in practice. And as I'm from Finland, the first example will be from there. So the data that Daniel mentioned is retrieved from various sources. So it can also be retrieved from global sources, but also local sources like getting the terrain, site boundaries, buildings from the National Land Survey of Finland, road data from the Finnish Transport Infrastructure Agency, as well as then the wind data from Finnish Meteorological Institute. And then we can bring this data into Spacemaker and run it through these algorithms, which then allows us to get near real-time analysis. So we get the 3D model that Daniel showed, noise analysis based on the traffic data, but also the wind analysis based on the wind data we get from the different sources. And if we go to an example and look more on the concrete, like for instance, wind. So here in the map, you can see that all the weather stations are the weather observation stations in Finland, and each observation station provides an insane amount of data. So if you take, for instance, the Kaisaniemi Observatory and choose the wind direction and speed for a time period from 2019, that is, we can now check the wind direction and speed, for example, on May 29th. And that could be quite interesting. It was actually the day when Finland won the last Ice Hockey World Cup gold. So it was celebrated outside here in the city center. And it could be interesting to know the wind speed at that time. But if you take then the average for 5 years and combine them, we get this wind rows where we can see how many hours on average in a year wind come from different directions and at what speed it comes. And this can be a bit more useful, but then if we take these wind rows and look at, or we combine these wind rows or this data we have here with the 3D computational fluid dynamics algorithm, we can then create a virtual wind tunnel. And this we can use to simulate different wind conditions in a region from a specific direction. And this can already be interesting when you want to explore how to design your concept and how will your building affect the wind condition from one direction. But it doesn't give you maybe the overall picture of the area of the situation. So if you then take it, all the observation for the whole year, calculate the probability and the average of all of these, and then combine them with a comfort scale or criteria, we can then estimate the wind comfort for pedestrians. So the purpose of this assessment is to describe the suitability of different areas for certain typical activities. So in this example, for instance, you can see that most outdoor areas are not maybe suitable for sitting, and some areas that are a bit darker in yellow or red can even be dangerous if you're cycling or for elderly. And actually, Andres' pedestrian analysis that you presented earlier would be really interesting to combine with this as well, because this gives you also an view of like where is it good to actually walk or sit or then have different ways of walking. But yeah, this was just one example of how you can take a large amount of data, combine different algorithms and criteria, and then get easy to understand analysis that we then can quickly, like for the architect or the developer, to allow them to make these informed decisions on the design of the area and where, for instance, to place restaurants or kindergarten or other things. And this is now, we have seen now the technology or the technology is there, so we have it. But in the end, it's more about like the people using the technology and how to implement it to their processes. And next, I will tell you about an ambitious project located in the north of Norway, where I also was involved in implementing this or our technology. And in this project, developers had a bold concept with the main goal to create a vibrant public street in a town known by strong winds. And the developers decided to implement a Spacemaker to make sure all parties could have informed discussions and speed up the whole regulation process. So we met with the architects, Smith Hammer Lassen architects, and the municipality and the consultants, and of course also the developer Clemens Eyendom. And together with the group, we understand how the street could be successful public space based on both wind conditions, but also other conditions. And now you can see here a comfort scale for the whole year, which is then based on these wind simulations for 8 different directions. And on the scale, you can see here also with the colors, red means that it's uncomfortable, and green means that it's good wind conditions or a bit better wind conditions. And as you can see, the group also understood that it wouldn't be easy, and the architects needed to iterate on this. As you can see here, they did hundreds of iterations on the concept and got analysis and wind analysis for all of them without involving other consultants. So they could iterate on it, see how it will change, and the whole process was then documented with the municipality. And as you can see, they improved the conditions significantly for the whole year if you compare it to the first proposals. So it was a dramatical change in it, even though it was small changes. And even now, if you see here, it's for only the summer, you can see that it's almost the whole project was green. And other conditions, of course, was also important to look at. So in, for instance, the sun conditions for different dates of the year, but also noise conditions. So noise analysis for not only the proposal they created, but also for the neighboring buildings and the surroundings. So get an understanding of how it will affect both the noise, sun, but also here is to see the view from the apartments. And also, especially here, as it's really near the sea, so also how many of the apartments has sea view, and how will the new proposal change the sea view or the view for the neighboring buildings, and be able to document it, get the data points to show, and have the discussion based on these data and this fact. So in the end, it speeded up the dialogue, saved time and resources, but also strengthened the whole planning process. So in the end, it's a win-win situation where the developers get quick and fact-based dialogues together with the architects, while also planning authorities can easily verify if the project performs as well as the context allows. But I guess the most important thing, or most importantly, is for the end users, the citizens, to get areas and apartments that are actually optimized for the living qualities and not only optimized for the financial qualities of the buildings. And this has been also, of course, tested in other projects as well, but I would like to maybe end with a quote from the developer that was in this project as well, that said that it allowed them to build or Spacemaker allows you to build an analytical basis early, on which you can build arguments that make the dialogue with the municipality better and more effective. By working iteratively and analysis-driven, we save time and strengthen our entire planning process. And we recommend other municipalities and city developers to work in the same way. So this was a good example of how, based on facts and data, you can actually create and iterate on a model and create, in the end, a better project.
Thank you, Raoul and
Thank
Daniel,
you.
for a great presentation. Spacemaker looks like a really great tool, and the way you showed that you can just select any area and have a 3D model, you can do analysis on it. Will that work in every part of the world, or is it limited to countries somewhere?
I can take this one. So data will vary from country to country. We have mapped Europe quite well. So we would get all the 3D geometries automatically. Where we are struggling the most, it's maybe the traffic information for most of the countries. But everything that you just saw is happening in an automated fashion. So you don't need the specialist to look for the information to actually be on the edge of this team to actually be able to work with data. is a very democratic tool. So everyone, even people that don't know any CAD tools, would be able to go through all of these analyses and start making good decisions. I think that's a very, very important part of this process.
Okay,
Yeah, and I
and what
can
has...
add.
Go ahead.
Sorry, I can just quickly add that also on Raoul Calvo's point there. It was also interesting to hear about the data availability and the government looking over it to get more data from the government that is the same and the quality is similar for all countries.
That was actually part of the question I wanted to ask is what has been your experience with the availability of data? Where is data most accessible?
Of course, me coming from Finland, I would say Finland. But no, I think overall in the Nordics, the data availability is really good. And I think that also Raoul Calvo pointed out that, and as Daniel also said, the traffic data can be a bit tricky to get in some countries as well. But overall in Nordics, I think it's similarly good. And Daniel, maybe you can add from in other countries as well.
Exactly. I think you have covered the most part, but what we have also made possible is that if that data doesn't exist, you can build it up very quickly. So in just a few minutes, you can actually create this 3D world and create inputs when it comes to noise. Even if you don't know those numbers, you can create conservative scenarios and just run those into your model. So that data availability doesn't become a roadblock to actually create a good project. So we do fetch that automatically for you through the software, but we give you the possibility to always impact and even iterate that data that has been fetched.
Okay, thank you guys.